You touch your face, your phone, your food, and countless other things countless times every single day. Each touch leaves behind invisible traces of life, oils, bacteria, even viruses waiting to hitch a ride. But there's one ordinary object that stands between you and this hidden microscopic world. Something so simple that we barely think about it. A bar of soap. To most of us, it's just part of a daily routine. But what if I told you that soap isn't just a cleaner? It's a molecular weapon. A substance so clever that it can break the laws of chemistry and physics, and even tear apart viruses that threaten our lives. This is the story of how a simple bar of soap became one of the most powerful chemical inventions in human history. Let's start with the basics. What exactly is soap? At its core, soap is a molecule made from fats or oils combined with an alkali, like sodium hydroxide. But what makes it special is its dual personality. One end of a soap molecule loves water. It's called hydrophilic. The other end absolutely hates it. It's hydrophobic, meaning it loves oil and grease instead. This strange combination gives soap its superpower. When you mix soap with water, millions of these molecules start spinning and rearranging themselves. The water-loving heads point outward toward the water, while the oil-loving tails clump together to avoid it. Eventually, they form tiny spherical structures called micelles. Inside each micelle, all the dirty, oily, or greasy particles, the stuff water alone can't wash away, get trapped inside. Then, when you rinse your hands, those micelles are swept away, taking all the dirt and germs with them. That's the cleaning part. But soap doesn't just remove things. It completely destroys them, especially when it comes to germs and viruses. Many viruses, including influenza and even COVID-19, are wrapped in a delicate fatty layer called a lipid membrane. This membrane is what protects the virus and helps it attach to your cells. But soap molecules love fat. Their hydrophobic tails latch onto that lipid layer and rip it apart. When that membrane breaks, the virus literally falls apart and becomes harmless. It's like poking a hole in a water balloon. That's why washing your hands with soap for 20 seconds isn't just hygiene. It's viral warfare on a microscopic scale. You might think hand sanitizers do the same job, but not quite. Alcohol-based sanitizers kill microbes by denaturing their proteins, but they don't physically remove dirt or grime. Soap, on the other hand, both kills and washes away everything at once. It's the double punch of destruction and removal that makes it so powerful. Now, there's something most people never think about. Soap doesn't just change biology, it also bends physics. Have you ever noticed how water tends to bead up on a surface? That's because water molecules stick tightly to each other, a property called surface tension. This tension prevents water from spreading easily or getting into tiny spaces. When soap enters the mix, it wedges itself between water molecules, breaking that tension. Suddenly, water can flow into cracks, coat surfaces evenly, and reach every corner of your hands. Without soap, water simply rolls over grease and dirt. With soap, it spreads, penetrates, and lifts it all away. Interestingly, soap's molecular design is so elegant that scientists have tried to mimic it in other fields. In nanotechnology, similar amphiphilic molecules are used to build microscopic capsules that deliver drugs inside the body. It's cheap, simple, and everywhere. Yet, it performs tasks that even complex disinfectants struggle with. It works without fancy technology, without electricity, and without needing a prescription. And yet, it's arguably one of the most life-saving inventions of all time. How many other things in your bathroom can claim that? So the next time you pick up a bar of soap, take a second to appreciate what's happening on that molecular battlefield.